What are we looking at today? Today, I'm Jono, and I'm going to be looking at equilibrium position for your GCSE chemistry exam in this revision episode. It's really commonly featured on exams. It's quite an application type topic, so you need to understand it really well. Hopefully, I'm going to do a good job at explaining it, so let's dive in. A bunch of different factors can affect the position of the equilibrium. If you want to recap equilibrium, listen to the previous episode of this series, because that will go over all the key definitions you need to know. But basically, equilibriums happen in reversible reactions, and Le Chatelier's principle will act to reverse the effects of any change on an equilibrium position. So let's start by talking about temperature. Changing the temperature of a reaction will take the system out of equilibrium, okay? So the system will try and restore the equilibrium when we change the temperature. So if we decrease the temperature, the position of the equilibrium will shift in the exothermic direction. This results in an increase in the products of the exothermic reaction and a decrease in products of the endothermic reaction. And this makes sense because exothermic reactions generate heat. So if we decrease the temperature, the equilibrium is going to be like, I want to increase the temperature. So the position of the equilibrium shifts in the exothermic direction, so we make more products that release heat to the surroundings. Okay, so it's just about keeping a balance. So with that said, what do you think happens when we increase the temperature? Well, something very similar happens, but this time the system wants to decrease the temperature to counteract the increase that we have put on the system. So the position of the equilibrium shifts to the endothermic direction. This results in an increase in the products of the endothermic reaction and a decrease in products from the exothermic reaction. And endothermic reactions, they take heat energy in from the surroundings, so cause the surroundings to cool down. Okay, so it's all about just maintaining a balance. And so what happens when we decrease the temperature of a reversible reaction? Products of exothermic reaction increase, products of endothermic decrease, and the position of the equilibrium shifts in the exothermic direction. When an equilibrium shifts in a particular direction, we make more of the products in that direction. So if we're making more exothermic products, we'd say that the position of the equilibrium shifts in the exothermic direction, okay? Next, we need to talk about pressure and the position of the equilibrium. Pressure only singular affects reactions involving gases. And to predict what happens after a change in pressure, we need to look at a balanced equation to see how many gas molecules are on each side, okay? So if we decrease the pressure, the position of the equilibrium will shift towards the side of the reaction that produces the most gas molecules, because we want to get that pressure back, okay? So if we decrease the pressure, the equilibrium shifts to the side that produces more gas molecules, because then when we have more gas, the pressure will increase. So similarly, if we increase the pressure, the equilibrium is going to shift to the favor of the reaction that produces fewer gas molecules, okay? So to predict the outcome of a pressure change, we have to look at a balanced equation and see how many molecules of gas there are on each side, okay? So a similar process applies to concentration and the position of equilibrium, but this is more in a solution, okay? So if we increase the concentration of a reactant, the position of the equilibrium will shift towards the products, okay? Because the system wants to oppose any change, so if we add more reactants, the system's going to be like, yo, no, I don't want any more of you. So it's going to shift the equilibrium towards the products to maintain the balance, okay? And similarly, if we increase the concentration of a product, the position of the equilibrium will shift towards the reactants, okay? So if we increase the concentration of a reactant, which reaction do we favor? The forward reaction or the reaction that makes the products. Pressure changes, what kind of reactions do they affect? Only ones with gases, okay? And quickly, let's review temperature and the position of the equilibrium. If we increase the temperature, which direction does the equilibrium shift? If we increase the temperature, the position will go in the endothermic direction. If we decrease the temperature, the equilibrium will shift in the exothermic direction. Okay? And finally, let's go over pressure. If we increase the pressure, we're going to shift to the side with the fewest gas molecules. If we decrease the pressure, the position of the equilibrium will shift towards the side of the reaction that has the most gas molecules, okay? And for that, make sure you have a balanced equation, okay? Now let's just do an example of a gaseous reaction. So if we have A goes to B plus C, and all of them are gaseous, what happens if we increase the pressure? Well, if we increase the pressure, the system's going to want to respond to reduce the effect of that change. So we increase the pressure, there's more gases on the product side than the reactant side, so the equilibrium is going to shift in the backward direction towards the side with less gas molecules. Because if we make more of the reactants, the pressure is going to decrease because there are less gas molecules. So that just about covers equilibrium and equilibrium position. I hope it was useful. Let me know what you think, and I look forward to catching you guys on the next episode.